Hello students, welcome to the lecture on Advanced Java. And after the lecture we will be able to learn the following objectives. Understand Java database connectivity. Describe an overview of RMI applications. Explain the concept of Java servlets. Discuss the concept of generics in Java. Explain the generic methods. Advanced Java implements advanced concepts like JSP, JDBC, struts, and Hibernate, etc. using core Java. One of the most dynamic programming languages used by computer programmers today is Java. This language has advanced through the years in both functionality and reach. Current editions are on the Java 2 platform, which is, not surprisingly, the second main incarnation of Java software. In JDK 1.0, a reasonably comprehensive set of features were provided. However, events such as mouse movements, button clicks, and window closing had to be handled in a way which led to inefficient code, and code that was inappropriate in the object-oriented system. The Java 2 platform has three basic editions: Micro, Standard, and Enterprise. They have increasing amounts of functionality and flexibility, with the Micro edition being used for small-range applications, and the Enterprise edition being used for large, server-based functions. In the middle is the Standard edition, or J2SE, which has applications up and down the requirements ladder, filling needs for both individual and complicated users. Let's now take a look on Java database connectivity. The JDBC, Java Database Connectivity API, defines interfaces and classes for writing database applications in Java by making database connections. Using JDBC, one can send SQL, PL/SQL statements to almost any relational database. JDBC is a Java API for executing SQL statements and supports basic SQL functionality. It provides RDBMS access by allowing one to embed SQL inside Java code. Because Java can run on a thin client, applets embedded in web pages can contain downloadable JDBC code to enable remote database access. JDBC architecture. Java application calls the JDBC library. JDBC loads a driver which talks to the database. One can change database engines without changing database code.
JDBC is a Java API for connecting to a database through the Java Virtual Machine, or JVM. The driver manager is a JVM service for JDBC communication. This diagram depicts a Java application connecting to the database through the driver manager. The driver manager in turn calls a low-level, vendor-specific driver to complete the connection to the database. Database drivers. There are 4 JDBC driver types depending on which device is facilitating the connection to the database. For our purposes, we will be using the Type 4 drivers to connect our Java project to the database. Later, when server-managed data sources are called by the Java application, a Type 3 driver will be necessary. The specific names of the JDBC Type 4 driver classes for the two popular databases, Oracle and MySQL, are shown. Remember, for a database connection, 2 files are required: the vendor-specific driver manager class and the library. Both of these are packaged together and referred to collectively as the connector jar, which is placed in the build path of a Java project. Now let's look at a Java project. Here we have placed the JDBC connection code in a class called Database Connection. Our test class contains a main method and will obtain the JDBC connection from the Database Connection class. Notice, too, the Oracle connector jar in the build path of the project. Registering the driver. As indicated, there are two ways of registering a database driver with the driver manager. The most popular method is through the use of Java reflection and the class.forName method. This will cause the JVM to load and initialize the class referenced by the string argument at runtime. Now let's look at the database connection class a little more closely. The getConnection method of this class accepts no input, but returns a connection object when called. Upon entering this method, the reflective class.forName is used to register the Oracle driver with the driver manager. Connection. Once the database driver is registered with the driver manager, the getConnection method is used to obtain a connection object. The connection URL, username, and password are supplied to the getConnection method of the driver manager. Now let's return to the database connection class. The getConnection method of the driver manager can now be invoked to obtain a connection object to return to the calling program. Notice the two imports are in the Java SQL package. These do not originate from the connector jar. Notice too that the getConnection method is static, as indicated by the italic script provided by Eclipse. Summary. JDBC is an API for connecting the JVM to a database. The Java application connects to the database through the driver manager. Connector jar placed in the project build path contains a Type 4 driver, a database vendor-specific driver for communication, and a library. Registering the driver is through Java reflection and class.forName. The JVM loads and initializes the driver at runtime. Obtain a connection with the driver manager.getConnection, passing the URL, username, and password.
Let's now understand about transactions with database. In simple, JDBC transaction makes sure SQL statements within a transaction block are all executed successfully. If either one of the SQL statement within transaction block is failed, abort and roll back everything within the transaction block. For better understanding, an example with JDBC transaction is shown. Let's now have a look on RMI applications. The RMI applications often comprise two separate programs, a server and a client. A typical server program creates some remote objects, makes references to these objects accessible, and waits for clients to invoke methods on these objects. A typical client program obtains a remote reference to one or more remote objects on a server, and then invokes methods on them. The RMI provides the mechanism by which the server and the client communicate and pass information back and forth. Such an application is sometimes referred to as a distributed object application. The given illustration on screen depicts an RMI distributed application that uses the RMI registry to obtain a reference to a remote object. Advantages of dynamic code loading. One of the central and unique features of RMI is its ability to download the definition of an object's class if the class is not defined in the receiver's Java virtual machine. RMI passes objects by their actual classes, so the behavior of the objects is not changed when they are sent to another Java virtual machine. Remote interfaces, objects, and methods. In a distributed application, some implementations might reside in some Java virtual machines, but not others. Objects with methods can be invoked across Java virtual machines are called remote objects. RMI treats a remote object differently from a non-remote object when the object is passed from one Java virtual machine to another Java virtual machine. Rather than making a copy of the implementation object in the receiving Java virtual machine, RMI passes a remote stub for a remote object. Compiling sources. As with any Java program, one uses the Java compiler to compile the source files. The source files contain the declarations of the remote interfaces, their implementations, any other server classes, and the client classes. Making classes network accessible. In this step, one makes certain class definitions network accessible, such as the definitions for the remote interfaces and their associated types, and the definitions for classes that need to be downloaded to the clients or servers. Classes definitions are typically made network accessible through a web server. Let's now take a look on remote classes and interfaces. The interfaces and classes that are responsible for specifying the remote behavior of the RMI system are defined in the java.rmi package hierarchy. The figure on the screen shows the relationship between several of these interfaces and classes. The java.rmi.remote interface. A remote interface must at least extend either directly or indirectly the interface java.rmi.remote. In a remote method declaration, a remote object declared as a parameter or return value, either declared directly in the parameter list or embedded within a non-remote object in a parameter, must be declared as the remote interface, not the implementation class of that interface. This is an example for interface bank account, which defines a remote interface for accessing a bank account. It contains remote methods to deposit to the account, to get the account balance, and to withdraw from the account. The remote exception class. The java.rmi.remote exception class is the superclass of exceptions thrown by the RMI runtime during a remote method invocation. To ensure the robustness of applications using the RMI system, each remote method declared in a remote interface must specify java.rmi.remoteException or one of its superclasses such as java.io.ioException or java.lang.exception in its throws clause. Protocol errors. The class remote exception is a checked exception, one that must be handled by the caller of a remote method and is checked by the compiler, not a runtime exception. The remote object class and its subclasses. RMI server functions are provided by java.rmi.server.remoteObject and its subclasses, java.rmi.server. Remote server and java.rmi.server.unicastRemoteObject and java.rmi.activation.activaTable. The class java.rmi.server.remoteObject provides implementations for the java.lang.object methods, hashcode, equals, and toString that are sensible for remote objects. Let's now understand the RMI architecture. RMI's purpose is to make objects in separate JVMs look alike and act like local objects. The JVM that calls the remote object is usually referred to as a client, and the JVM that contains the remote object is the server. In RMI, the term server does not refer to a physical server or application, but to a single remote object having methods that can be remotely invoked. Similarly, the term client does not refer to a client, but actually refers to the object invoking a remote method on a remote object. The same object can be both a client and a server. Let's understand the RMI object.